Okay, this is worksheet 1-1, problem number 1. It asks, a line containing point X. Well, first step is you want to find X. Where's X at? X is right there. So we need to find a line that goes through point X. Well, the easiest one to see is right here. What is that line called? Line M. Right here. That is not the only way to name it, though. You could also name it by 3 points on that line. Or 2 points on the line, I'm sorry. How about these 2 points, X, Y? Is that right? Nope. You forgot to put the hat. You have to put the hat on. What's another way to name that line? X, R, yep. Y, R. Y, X, it's right here. You could switch around, that would be correct. I'm not going to write that down, though. Okay, so there's at least 9 correct answers right now. There's actually more. Okay? I am telling you right now, there are 2 more lines that go through X. Only one person in all of my classes has got this right on the first time. Let's see if we can double that. Okay. N. This is line N. Is that going through X? Nope. X? X is a point. Line M is right there. We've already labeled that 4 times. There's other lines. W? You are 100% correct. Good job. Who said, you guys see that line right there? Who said you're not allowed to draw lines in? Okay. Any 2 points make a line. Okay? That's what you just said, yeah. Any 2 points make a line. So XW is a correct answer. I told you there's 2 like that. You've only found 1. Where's the other one? Z. X, Z. There's another line right there. I forgot. This got clipped off. This is supposed to be line L. This is supposed to be X down there. Point X right here. Okay? So, remember, sometimes you're going to have to draw in your own line. Sometimes you have to draw in your own planes. Okay? That's always an option. Think outside of the box. Problem number 2, a line containing Z. Remember, Z is down here. This is L. Okay, what line contains Z? Line L. We got that from right here. So you'd write that, right? Nope. You'd have to write line L like that. Okay. What's another way to name that? R, Z, or C? C. I thought you said C. R, Z with the hat. Also ZR with the hat works as well. That's the same line. Okay? Just like before, there are 3 lines you can make that are not drawn. First one here, second one here, last one here. Okay? Don't forget those. Any of these is a correct answer, though. Okay? Do you have a question? So do we all understand? Did I explain this well enough? Do we all understand what I'm talking about? Okay. Yeah. Just remember you can draw in your own lines. A plane containing W, R. Plane containing W and R. Plane B, yeah. Plane B, remember that's from right here. That is not a point. That's plane B. Okay. I have a question. How many points does it take to make a plane? It's in your notes. 2. Double check your notes. 3. It takes 3 non-collinear points to make a plane. Okay. So, can we find another non-collinear point on this plane? X, RW. You don't. Why is that? RW what? x. RWY would also be another plane. Okay? So we have plane WRX, plane WRY. These are all the same name for one plane. All these are the exact same name for the same plane. Just different ways of labeling it. Okay? There's actually a hidden plane that's not drawn in. That's also another answer. Does anyone see where it is? Well, it's just not drawn in like the lines. It's there. 100% correct. The Z. W, R, Z. That would be another plane. Now, that looks really weird because in 2D, what it would look like in 3 dimensions, if this is plane B, you guys see how that's plane B? This would be plane WRZ. It'll be going down like that. Does that make sense? It would look kind of like this. You guys see what I'm saying? It's below this. It's below this plane. It's hard to see because it's in 2 dimensions, but it would look like that. Okay? Am I crazy? No? You guys see what I'm saying? You're just saying yes? Yeah. Okay. Okay. This plane here that's drawn in is below the other plane like this. Remember, planes are flat surfaces, so it's actually below it. Okay? Or I guess if you want to think of it behind it like this, and that's why you can't see it unless you rotated it like that. Okay? Let's move on to the next one. Name a line that contains point Y. What line contains that point? M does, yes. What other line? Yeah, N. And then you can name them the different ways. It doesn't really matter. I'm not going to do that because there are 2 valid answers. You could call it line YW. You could call it line X, Y. Doesn't really matter as long as it's those 2. As long as it is those 2 lines. XR, yeah, it's a valid choice. Moving on. Am I going too fast or are we good? Okay, what is another name for line M? Highlight line M really quick. What are 2 points on that line? RY, sure. RZ. Wait, no, not RZ. RZs would be down here. RX. Okay, there's one more. No, not M. How about XY? Perfect. And you could switch these around, and it'll still be the same thing. Okay? Am I crazy? You look at me like I'm crazy. Okay. You're good now? Good. Name a point not on XY. Yeah, X. Okay. So what's first? You're right, but let's first label this. There's our line we care about. X to Y, so all of this. Z's down here. There's actually 2 points not on there. What 2 points aren't on there? W, Z. Yeah. W and Z. Okay. Any questions on this one, or can we move on? We're good there in the back? She's like glaring at me. Okay. What is another name for line L? Where's line L? It's right here. 2 points on it. The only 2 points on there are RZ. So the only 2 options you have is RZ, RZR. What's wrong with both of those? They don't have the hats. You know how I read this? If I was grading your homework, point R, point Z, point Z, point R. That's exactly how I would read that. It is not line until you put this symbol on it. Okay? And trust me, I would not make you do that unless you absolutely had to. Okay, that's not because I'm trying to make you do extra work. It means completely different things. Next one. Name a point not on line L, which is right here, and not on line M. Yeah, there's only one point right here, W. All right, any questions on your homework? All right, last freebie homework. Moving on. All right, our TEK for today is going to be to distinguish between the undefined terms, what I want you to learn by the end of today. So if you do not know this, you need to come see me. I want you to learn basic and academic vocabulary such as intersection, collinear, coplanar, non-collinear, and non-coplanar. Okay? If you do not learn those 5 vocab words by the end of today, we're having problems, right? You need to talk to me. Rope activity, okay. It's going to be really fun recording this because they're not going to see anything we're doing, but maybe they can listen. I don't know. I need a volunteer. All right, come up. Grab you a rope, hold it in one hand. It says, our hands are points. So this is one point, this is another point. She's holding a rope in one hand. Can she make a line? Now I want you to make a line. Or you can just make it droopy on one side. Make it tight. Yeah. There you go. OMG. Okay. So, how many points did that take? How many hands did that take to make an actual line? 2. So, what's the answer to that first question? 2. What do your hands represent? So, how many points does it take to make a line? 2. The 2 points is what gives the line direction. What do I mean by that? This line, keep it tight. This line is different than this line, right? Different directions, and it's from the second point. Second point makes this different, right? You can move it all over the place. There's an infinite number of ways we can do it. Because it can start coming out here, it can be up here, it can go down there, it can go behind her, all sorts of different ways. We need to stay up here for a little bit longer. We need 2 more volunteers. Here, come up. Just come up. You weren't fast enough. All right, grab a rope. Grab a rope. Each one of you need a rope. Okay. Grab the end of her rope there and hold it in one hand. Hold both of your ropes in one hand. Perfect. Now grab the end of his rope, hold it in one hand, and then go to the end of her rope and hold it in one hand. Oh, sorry. You need to hold this one here. Now make it tight. So spread out and make it tight. You might need to shrink it. Use 3. And just make it tight. All right, perfect. So, how many points? This is a flat surface, right? That's a definition of a plane. How many hands did we need minimum to make that? So, how many points did we have to use to make that? 3 points. So, you need 3 points to make a plane. Now, this is going to sound really corny, okay? I like to think of planes like the surface of a pool. Pretend this is the walls of a pool, this is the surface of it, okay? The plane itself is only the surface of the pool. Anything below it down here is not in the plane. Anything above it up here, not in the plane. Think about taking a floating ball, throwing it into a pool. It floats on the plane. Doesn't go below it, doesn't go above it. So everything in here is part of the plane. Okay, does that make sense? All right, you guys can sit back down. Round of applause for our lovely volunteers. Was the rope, I told you about being more physical today. Was this everything you ever dreamed of? Don't have enough ropes. What? Okay. On page 29 of your ISN, I want you to write these 4 bullets down. We're going to write intersection, that's our vocab word, and this is everything about intersections. We have some challenge questions going on. You do not need to write down the challenge questions, but I want you thinking about these as we go through this. I made a mistake here. This is not supposed to be points. This is supposed to be planes. 3 planes intersect at a blank. Yes, title, the word intersection. And the answer to that is not a fiery crash. One person got that joke. He says that joke's lame. All right, I'm going to give you guys 5 minutes to finish this. Yeah, write these down. Okay. The definition of an intersection is, and this the text, I got this straight from the textbook, a set of points common to 2 or more geometric figures. What are geometric figures? Lines, planes, boxes, all sorts of stuff. What does this really mean? I guess in non-jargony terms, wherever figures touch each other, where 2 lines touch, where 2 planes touch, where 2 boxes would touch, stuff like that. So I need my 3 volunteers up. It can be different people this time. Uh-oh, we have 4. Okay, grab a rope. Make a line with her, and you're going to make a line with me. Yeah. So you hold, bring that rope to her, and yeah, I'll take this rope. Okay, make them tight. Can we all see this? Okay. Are these 2 lines intersecting? No. And a common misconception is if lines cross, then they're intersecting. Are these lines crossing? Yes, they're crossing, but they're not touching. That is an intersection. And where does that intersect at? Right here. Is this a point or is this a line? A point. 2 lines intersect to form a point. Okay? What's this? Move right next to him. Put your hand above his. What's this called? Up. Move it up. What's this called? Parallel lines. It would also be a plane going like this. You're the first person to say that. Good job. All right, you're going to stay here for a little bit longer. So 2 lines intersect at a point. Okay, the next one. It's asking 2 planes intersect at a what? Well, we have 2 examples. We have a bunch of examples of planes in this room. Best one I can think of is this wall. A wall is a flat surface, correct? And a plane is also a flat surface. So we have a flat wall, flat ceiling. Do you agree with me? So, where does this wall touch this ceiling? At a single point or at an entire line? You guys see that metal line right going across there? So, 2 planes always intersect at a line. The boards do too. All right, so we're going to make a plane again. So you need to hold, how about you hold these between each other? It's all good. Take this. Take this. How about you move kind of over there and you guys kind of switch around. Okay, I guess that works. No, hold that. Now, make it tight. Perfect. Hold it in one hand. Hold it in one hand. Okay, we made our plane. Do you agree with me? And the reason why I made a plane is because a plane and a line going through the plane intersects at a what? It is a point. So, we take our line. We have this line going through this plane. Do you guys agree with me? Is this, and remember, the plane is like the surface of a water. Is this touching the surface of the water at a line or at a single point? A single point. How about now? 2 points. One here, one there. Well, there's a line between those 2 points. Yeah. All right. We're done. Thank you. You have to clap like you mean it. Thank you to my volunteers. So they intersect at a point. My challenge questions. First challenge question was, 3 planes intersect at a what? At a corner? Yeah. 3 planes can intersect at a what? I want you to look at that corner right there. Look at the green wall, the white wall, and the ceiling. Where do those 3 all touch at once? That corner. Right? They all touch at that single corner right there. Do you agree with me? Is that corner represented by a line or by a point? So 3 planes intersect at a point. Next question. This is more theoretical. Can 2 points intersect? So we have this point here, and we just said we need to make another point touch that point. Wasn't that just the same point? So are those really intersecting? No, it's the same point. Okay? So, no. Okay. So I want you to visualize a pool for a second. And you know the swimming lanes in pools? They're made out of little plastic discs. Okay? You know how those go across the pool? So we have our plane, which is our surface of our pool, and we have our swimming lane going across it like that. Remember, planes, you can intersect across a plane as long as it's touching the surface of the water. How many times does this swimming lane touch the surface of the pool? Just 2 times? The entire time. Now, if the pool lane goes on indefinitely, forever, and the pool also goes on forever, how many times is it touching the pool? Forever. Infinite number of times. If you have a line on a plane, it is intersecting an infinite number of times. Does that make sense? Perfect. You guys got that the best. Maybe I explained it the best there. I was a lifeguard, that's why I keep talking about pools. I was also on the swim team. All right, collinear, coplanar. I want you guys to write this in your ISNs. I'm going to give you guys, like, I don't know, 30 seconds, 45 seconds to write this. Then I'm going to get some unfortunate volunteer, you might have to get voluntold, to come up here and fill in those blanks for me. You want to do it? Okay. Give people a chance to write, though. I saw you earlier today. With Shaq? I like Shaqlovitz a lot. It is. All right, you want to come up? He's going to fill in a blank. What does the word co mean? It means the same. I know. And that makes your handwriting even worse. Linear. What does linear mean? Watch this, guys. Right there. Line. Means line. And I want you to fill in the other 2 blanks. Co means same. It's getting bigger and bigger. Now it's getting smaller. Planar means plane. Pilot? I don't think it means... actually, a lot of my students are coplanars. Just think about it for a minute. No, I think he's the only one that got it. I'm hilarious, thank you. All right, I'm going to draw you guys two examples, one or both, okay? Collinear, same line. Are these points collinear? Why? Because they're all on the same line. Coplanar is a lot harder to draw because it's supposed to be in 3 dimensions, but something like this. Are all those dots coplanar? Are all those on top of the water? If you were to take a, you know those, a bunch of those floaty balls, right, and just dump them into the pool, all of those balls would be coplanar with each other because they'd all be floating on the surface of the pool. Does that make sense? Perfect. Now we have non-collinear, non-coplanar. Non, not, same line. Not the same plane. Okay? I'm going to draw you an example of non-coplanar. Sorry, non-collinear. Is that non-collinear? It's supposed to be all on a straight line. Let me redraw that to make it a little bit better. Are those 3 points non-collinear? Absolutely not. They are collinear. I'm going to make these non-collinear by doing one thing. Are those 4 dots non-collinear? Are all 4 of those dots on the same line? Then they are non-collinear. Okay? You guys see what I'm saying? Let me move that pen so you can actually see it. Right? All 4 of those dots are not on the same line. All right. Non-coplanar. This one's the hardest one to draw. I'm really bad at it. Okay. Are all those points on the same plane? Are they all on the same surface? No. We have some that are above and one that's above, one that's below. Does that make sense? I know it's hard to see there. That's what I'm trying to represent here. This one's above, this one's below. So, do we understand all 5 of our words? Did we get through all that? So, our words were intersection, non-coplanar, non-collinear, collinear, coplanar. If you do not understand one of those words, you need to talk to me. Okay. Your exit ticket is to finish this in your ISN. Yeah. You guys are almost done. Good? All right. Your exit ticket is right in your notebook. Finish the sentence stem. In Greek, the word geometry means, I told you on Monday what it meant. Geo means earth. Your homework for tonight is the same sheet, problems number 16 through 22. Remember, this will be graded tomorrow. One last thing I want to show everyone. I created a, is this it? Or is this, yeah, this is Schoology. In Schoology, you guys should know about Schoology. I created a virtual ISN for you. What this is for is maybe I went too fast and you weren't able to write everything down. Okay? So, your ISN should look very similar to this one here. And let's say you wanted to go to today's or yesterday's notes. It's going to be about a day behind. You click through it until you get to that day. And, oops, I want one too much. Too many. Right there. There's yesterday's notes. This does not replace your ISN. This is solely if you messed up, or if you missed a day, maybe you messed up, maybe I went too fast. Okay? Use this tool. This is not a replacement for your ISN. I will grade your ISN. I will not grade that. And it's going to be maybe a day or two behind too, because I actually have to put it in there. Okay? I didn't get, oh, because we ran out of time. All right, so on this page, we ran out of time yesterday. Space, should be on page 27 and 28. Space is a boundless three-dimensional set of all points. Basically, everything around us is space. We work in space, okay? All the lines, all the planes are all inside of space, okay? You know how a line goes from a line to a plane, you add a dimension? From a plane to space, you add a dimension, okay? Space is 3D, planes are 2D, lines are 1D. Can you guys read that? Is it big enough for you to read? Sorry about that. I forgot we didn't go through that. That's as big as it's going to get. All right.